There are several types of rational functions that we'll be graphing in this unit. In this section particularly, we'll be talking about simple rational functions, and I want to point out that that does not mean the functions we'll be graphing in the next section are hard rational functions. It just means we're going to generalize the rules in the next section. We're starting off with baby steps really for this section, just to get used to what a rational function looks like. So the definition of a rational function is a function that is in this form. And here I just wrote that f of x is p of x over q of x. And those are two different functions, remember. I have function notation here that we have f of x, and that result is the quotient of two different functions, p of x over q of x. And we've seen some type of rational function already in the first section that we saw in this chapter, 8.1, where we were looking at a function that looked like this. We had a constant on top, which we called a over x, and x is our variable, so now it's in the denominator. Now, this function in red is called inverse variation as well, and you saw that where a is just your constant of variation and x is your variable. And so that's where we're going to start off in this lesson, is graphing what these rational functions look like. And if you look down here, you can see that your rational function actually has two branches. So you have one part of your rational function here and the other part up here. And when you have two branches like this, it is called a hyperbola, and that's written right there. And so we will look deeper into the hyperbola, but I wanted to kind of make a table so you could see why this thing looks the way it does. So let's begin entering some numbers. So if I put in a -3 for my x value, and let's say that this constant on top was 1 over x, and I put a -3 in, you can see that you're going to get a -1/3. If you put in a -2, you get a -1/2. If I put in a 0, something happens. You're not allowed to put a 0 in the denominator. You hopefully remember that. And so that is what is producing this vertical asymptote right here. When x equals 0, you end up with a 0 in the denominator, which is just not allowed. And so it is a place where our curve cannot cross because we can't enter 0 as an input. And then you should notice that you could switch to positives. If I put a +2 in, I get 1/2. If I put a +3 in, I get 1/3. So then my question is to you, what number could I put in for x where I would get 0 as an output? And hopefully you thought for a while and thought, hey, I don't see a number I could put in for x and get a 0 as an output, which would be very astute, and that is why we have our horizontal asymptote. We never get 0 as an output in this situation. And so once again, these two branches are one graph. They work together, and it is called a hyperbola. So if you look at the definition written over here, where it says that talks about the domain and range, you can see that it says the domain and the range are all non-zero real numbers. So any number can go in for x as long as it isn't a 0, and you will get this graph. So for domain and range, it is all non-zero real numbers when you are plotting the parent of y equals 1 over x. So let's start by graphing this rational function of y equals 6 over x. And we start by graphing the parent function. So your first job is to graph the asymptotes, and those aren't any different than you just saw. You cannot have 0 as an output, so you have an asymptote there, and you cannot input 0 because you would get a 0 in the denominator. So you have two asymptotes. Your next job is to plot points to the left and the right of the vertical asymptote, and I'm going to write this down. Alright, and there I wrote that, and just to point out that instead of writing vertical asymptote all the time, I will abbreviate it with a VA. Okay, so we drew our asymptotes, and now we need to plot points to the left and the right, and so it's always the vertical asymptote, and that's located at 0, so go ahead and we'll pick some points around it. I kind of already did it for us, so we don't have to sit and calculate. So for my x values, I picked a -3, a -2, a 2, and a 3. You could have picked a 1, I just didn't. So if I put in a -3, out came a -2. If I put in a -2, out came a -3. And then this is how the rest of it worked out. So then when we plot these at -3 and -2 and -2 and -3, we can kind of see that branch. Remember, those branches' endpoints are approaching the asymptote but not crossing. And then on the right side of the asymptote, we have 2 and a 3 and 3 and 2. Oops, I did not do that right. 3 and 2 right there. And so then you draw those again with the endpoints approaching the asymptotes but not crossing, and there's your hyperbola. I would like you to do guided practice number 1 and number 1 only, because we haven't learned the others. And the interesting thing to look at for number 1 is you have a -4 for your value of a. So maybe think about what a negative a value has done with all the other functions that we've seen up until this point. But give it a shot. Remember, your first job is to draw the asymptotes. Your second job is to plot points to the left and the right of the vertical asymptote. Pause the video now and practice. Alright, and that is what your hyperbola should look like. It is a reflection of the hyperbolas we've seen up until this point, and that is because your value of a is negative. I should also point out that you are not limited to just graphing 2 points to the left and 2 points to the right. If you're not understanding how the branches are behaving, go ahead and do more points. But I'm happy with 2 on each side generally. But again, you're not limited.